welcome in. All right, there we go. Well, hey, welcome everybody once again to Astronomy Daily Live. Ding! We are live. So yeah, I hope everybody's doing well out there in the universe and the world. Um, yeah, it's pretty amazing circumstances that we sort of find ourselves in on this, what seems to be right this spinning, revolving uh, uh, object that we find ourselves on, sort of its surface, right? I mean, there's all this stuff inside, and there's all this stuff outside. We're just on this thin little surface. It just, hurtling through who knows where. You know, honestly, who knows how fast, right? I mean, we have a pretty good idea, but yeah, it's just it sometimes amazes me, that we find ourselves here at all, right? I'm a big fan of Alan Watts. He and in one of the lectures he gave, he was talking about this idea, that maybe we're some kind of being in this room, right, that has all these buttons, right? All these buttons, and each of these buttons, there's like, gajillions of buttons, right? And each one of those is, some kind of either experience or some kind of lifetime or something, right? And it's like, we've spent, zillions and zillions and zillions of years just pushing all these buttons, right? But there's one button, right, that is never pressed until the last one, right? And it's the button that says "surprise me," right? And so we decide to push that button, and here we are. So yeah, that's how sort of, sometimes I like to see things, and yeah, if this is like a big surprise, yeah, it's doing pretty good. Yeah, I mean, I'm surprised practically every single day. So, there's some kind of a surprise, and I love surprises, so no problem at all. All right, I'm going to check the chat window here really quick, see what kind of shenanigans are going along there. So Carolina Sky Astronomy, hey Jim, nice to see you again. Thanks so much for coming in. Chuck, hey, nice to see you there too. Tom, great to have you in the chat. Excellent. And Chuck is working with some symbols there, which I'd never seen those. Okay, so that's a mouse 3 button, that's a pause button, that's a stop button, and that's a record. Very cool. Okay. Well, it's always amazing what little graphics we come up with. These little emotes. They remind me of way back in the day. In like the 80s, right? When your object, like in a game, okay, was actually that pixel size, just massively blown up, right? So yeah, I think things are just coming around as they do. So all right, well, cool. I want to say howdy to Bobby in the panel.
Hey, good to see you, everybody. Great. Yep.
All is well over there in the swamps?
Yep, everything's there in the swamps. All is well.
All right, excellent.
Just, I don't know. Want to let you know that Tim won't be joining us. He's got an early day in the morning when the sun goes up in the UK.
Yeah. Well, the sun is coming up in the UK in just a couple hours, in just a few hours. So yeah, yeah. I think it's absolutely fantastic how just this little old channel, nothing, right? I mean, just tiny little thing. Um, just little old us, slowly growing, but uh, has such an incredible worldwide audience, right? We have a couple from the UK who pop in pretty regularly. We have a couple Australians, um, at least one, I think maybe two. Brazil has chimed in. There was a fellow for a little while from Afghanistan who was chiming in from time to time. I'm trying to think. Wasn't there somebody from Iran? Do you, I think I remember somebody maybe from Iran. Um, I'm trying to think where else. But yeah, it's just this
Kind
nice
of been crazy
worldwide.
where maybe just be better if you have a map
Yeah, yeah. I could definitely
with
just
push bands to find out where they're from.
yeah, yeah. Actually, the analytics that I have access to would actually tell me all of that. So yeah, that's exactly true. I don't really pay attention to the analytics on this channel at all because that I'm I'm gonna let this YouTube channel grow and evolve as it wishes, right? I'm just gonna sort of do my thing, and my basic job, right, is to be here every single day at the same time and talk about astronomy, right? Talk about astronomy and science and space and nerdy things like that, right? Speaking of nerdy things, so you remember yesterday we were talking about the fact that the full moon at the moment of the full moon is actually very, very close to the moment of the equinox, right? Well, um, I realized tonight that my particular location on this planet, right, has a third interesting aspect to that, and that's exactly what I was just about to look up now. Um, what is going to be happening here, right? This is Mountain Standard Time, right? This is the only time that this is going to be happening on the entire planet, right? Um, is that the full moon, right, at the time of the full moon is extremely close to the time that the moon rises in my location, right? So what I'm going to find out right now is what time the actual full moon is, and then when does the sun set, right? Because at full moon, the moon is completely on the opposite side of the sky. So as the sun sets, the moon rises. So at full moon, right? At full moon, when the sun sets, the moon rises. Doesn't matter where you are, right? But but that only occurs at the time of full moon, right? So I know when my sunset is, and I also know when full moon is. So let's see how close those two times are. So I think I'm ready to go here. So I'm going to share my screen, and I'm going to do that, and I'm going to do that, and here we go. So I'm proud to be able to use the MMT Observatory's Observer's Almanac to to tell me when my when all these various times or when all these various events take place, right? And what I'm interested in is going to be the sunset for tomorrow, right? And so this is local time, right? So it says 18. I don't know if you can see that or not. So for March 20th, sunset, right, which is moonrise.
And I'm looking at the time zone offset, and it says it's got a positive 7. It should have been negative 7.
You're saying?
Yeah, scroll to where
I
you
see.
say.
Yeah. I see that. Yeah. You know that, Bobby. You're exactly. Well, now let's think about this. I think that's correct because UTC is 7 hours ahead of this time, which is my local time. So I think that's a correct representation. I think that's right. At least how, I think that's how I'd interpret that. Anyway, so sunset or moonrise is happening at 1835 local time, right? Which is 1835, and we want that to go to 7 hours ahead. So 18 plus 7 is 25. So 135 UTC. Yeah, that sounds right. So 135 UTC is the time of my local moonrise. All right, 135. So now we can go over to the time of the full moon, and you will see that it's happening at 1:43. Wow. So that's super duper close. What did I say it was? 1:35. So yeah, I think that's pretty neat. That's only going to happen at my longitude. So nobody else gets to see that. And it's kind of strange because I've seen that quite a few times from my location. I don't think that there's anything special about my location, but I've seen this a number of times, right? In fact, I've seen a lunar eclipse rise. So, that means things are seriously lined up, right? Anyway, so yeah, I thought that was kind of neat that not only was it, within a few hours of the full moon and the equinox, for me, it's actually within a few minutes of the full moon. Is moonrise. So pretty cool. Pretty cool. Just thought that I would share that with everyone. Gloating a little bit because I get to see a cool thing and nobody else does. Well, I appreciate that, Jim. As I said, I don't really have any plans. I'm more about just having a good time, showing a passion, trying to put that passion into others, and not necessarily the passion for like space or astronomy or anything, but whatever your passion might be, right? And I think it's pretty safe to say that everyone has at least one passion, if not more. And you know, I mean, it's completely yours, right? Anyway, so yeah, I thought that that was a nice alignment. I'm going to make sure to be observing that tomorrow. So now that just sort of leads into the fact that tomorrow at, let's see, do I have that info? I guess we can find it over on Cloudy Nights when Equinox is, because this is the Equinox, the Happy Equinox ADL. So this is it. We will not see each other again until it is past the equinox. So this is it. Let's see. I think he listed when the equinox happens. 2158 UTC on the 20th. Okay. So that happens at 2158, and then the moon is new at, what did I say, 143? Oh yeah, here. Full moon 143, and my local moonrise 135. So that's going to be a pretty epic moonrise on, basically on the equinox. So I like it. That'll feel really, really nice to have that kind of alignment. All right, well, cool. So I'm going to, yeah, you know, as you know, Jim, there is so much to see, just to see, right? Not to measure, not to study, not anything at all, just to look. Holy moly, you're going to be busy for many, many lives. Yep. All right. Well, I've got a little bit of coffee left. I heated that up, and it didn't really last very long, but I've got a little bit left in there. And if we come down over here, we'll stop sharing. So yeah, you can see that there's just a little bit left way down there. Still all right. And then, of course, the hydrogen hydroxide. So yes, nice full mug of that stuff. So cheers. All right, so I did end up doing an OBS session yesterday, and the best way to learn things is the hard way. As long as some kind of learning or some kind of growth has occurred, sometimes the learning is a painful thing, and that's exactly what happened to me yesterday. So I was going after, or at least I decided to go after, an eclipsing binary star called GQ Tau. That's up in the constellation of Taurus. And this was a system of two stars that are going around one another, right? And it just so happens that their orbits are such that their line of sight, one component passes in front of the other one, right? And that changes the brightness, right? We can't see both of those stars, right? We don't have the technology to be able to separate those two stars out, right? So what we see when we look through a telescope, right, is we just see just one bright thing, right? But that bright thing is changing in brightness in some way. And that could be caused by intrinsic things, or it could be caused by extrinsic things. So those are the two primary modes of being a variable star, right? One mode there is a single star, basically, doing this, right? And I still haven't figured out if it gets brighter as it shrinks or if it gets brighter as it expands, right? I've always thought that it would look brighter as it expanded, right? Because it's doing this, right? It's going small, big, small, big, small, big. And so I always thought that if it was bigger, that's more surface area, and so you're going to see more light. But what I've recently read, I think on this live stream, a couple of papers about how the luminosity, is that right? The luminosity light curve is exactly opposite the brightness light curve. So it actually gets more luminous at the troughs and less luminous at the peaks. And yeah, I'm not understanding that much. Anyway, that's one type. Those are the intrinsic variable stars, right? Then you have the extrinsic ones, which are like eclipsing binaries, where you have two stars going around one another, and it just so happens our line of sight, one of the components pass in front of the other, and that usually causes a dimming, which can last, several hours, right? Then once you get into, how often does this occur, right? What's the period of these things? How long does it take? Then you start going into subcategories, right? So I think, yeah. And I think in terms of variable stars, I don't know how many categories there are, but there are at least dozens of different categories. So anyway, this GQ tau is an eclipsing binary star, obviously in the constellation of Taurus, and it was clear last night, and the timing was such that it was supposed to reach its minimum, right? So it starts relatively bright, and for most of the time, it is that bright. I think like magnitude 11.2. But then during the eclipse, it actually dims to a magnitude of about 12.2, right? So one magnitude, which is a factor of 2.5, right? So that happens, and then it starts to brighten again, comes back up. That whole cycle, right, from just when it starts all the way, to when it ends, it sort of looked like from the other light curves that we looked at here yesterday that it could last, like 4 or 5 hours or so. So yeah, so that was the target, and did the live stream here yesterday. Was anxious to get out there, got out there, and did the usual alignment, the star alignment, got everything focused, and dialed in the right ascension and declination for GQ tau, and punched the button, and it slewed over, and well, I I spent about the next a little over an hour trying to find this thing. Now that is breaking one of my rules, right? My rule says that if you can't find it in 10 minutes, move on, right? If you can't find the next one in 10 minutes, then check your alignment, right? Make sure that the telescope is, properly pointing, because I've proven to myself that if that star pattern exists on, that I'm seeing in my little tiny field of view, if that pattern of stars exists on the finder chart that I'm using, then I will find it, right? It doesn't matter what the orientation is. It doesn't matter if it's flipped. I don't care. I will find it, right? And I can find those things usually in a couple of minutes, right? And so that's why I'm like, okay, I'm going to give myself 10 minutes, maybe 15, right? Maximum 15. And then if I don't find that first one, the rule is to move on, right? Well, see, I sabotaged myself last night because I did not have anything to move on to. I did not have a second object I was going to be observing, right?
So Jim must know if you use plate solving or wherever that is.
I do. If I need to do astrometry, right, which is one of the services offered, right, then yes, I definitely do have to plate solve. What that basically is, Bobby, is there is a way to figure out which stars are which in my little field of view there. You can actually match that to a star catalog, right? And you might give the star catalog a little bit of help and say, this is where I was pointing, and this is approximately the field of view that I had, right? And with that information, there are programs that can identify what stars those are, and then calculate these mathematical coefficients that go into some equations that translate x, y pixels to right ascension and declination. And that is a useful thing because that puts these objects back up in the sky, right? As opposed to being on a computer and just being a picture, right? So that those kinds of plate solutions too also have some higher order terms, so it can take out like any kind of curviness. You might imagine. And this is a great exaggeration, but the surface of a CCD chip is like a potato chip, right? It's all lumpy, right? And so the plate solution can also take out at least some of those lower order terms like curvature and I don't know what the next one is, astigmatism. I'm not exactly sure. So yes, when I'm doing astrometry or when I'm trying to identify which star is which, so I can do photometric comparisons, to catalogs and whatnot. Yes, I definitely have to run it through a plate solver. And my go-to one is astrometry.net. That seems to be a great site, and they keep their star catalogs up to date. They're using Hipparchus right now, which is just fine. And I've been really happy with the results that I've seen from that site. So check out astrometry.net if you haven't already. Astrometry.net. Just like that. So yeah, and you know, probably what I mean. We can do this. Yeah, I think at some point we should probably get onto that site, and I'll just show you, you know, how to use it. I don't have any great insight into, you know, what the algorithm actually is or does, but it seems to do a good job. You know, I when I'm doing one by one binning, I've got about a third of a pixel accuracy. So that's about a third of an arc second accuracy when I compare my astrometric positions to like Gaia, right? I'm getting about a third of an arc second errors. So yeah, great tool. Cheers.
Got the faucet water right here. Cheers.
Excellent. Yeah, Jim, I'm always looking for a bigger cup. I've got, and I've shown this one before, but you know, I've got this one, right? Which you know is pretty big, right? That's right next to my head. Here's a, let's see, here's a smartphone, right? This is an S7 smartphone. You can sort of see how big that is.
What kind of stars are good for beginners to observe and take weight curves?
Well, Chuck, you know, there is an eclipsing binary star that is visible to the unaided eye, and that star's name is Algol, Algol, Algol. And as I said, you don't need a telescope, you don't need binoculars. You just need to be able to see relatively faint. I don't remember exactly now what the magnitude range is, but I want to say like second magnitude to third magnitude, or yeah, I don't remember exactly. And the actual eclipse lasts only for a few hours, right? I think it's like 5 hours or something like that. And I know that Sky and Telescope publishes the minima of Algol. So that is a date and a time when Algol is going to be at its faintest, right, in mid-eclipse. So I would say, as far as a beginner goes, that's a good one, right? And the cool thing about Algol is that it's situated right next to another star, and I think I've got this right. So when Algol isn't in eclipse, then it and its little friend right next door are about the same brightness, right? But when it's in eclipse, Algol is very noticeably dimmer than that other guy. So that's a way to estimate brightness or magnitude, and you can usually get, you know, to within 1 or 2/10 in terms of accuracy there. So you know, that's not bad for just visual stuff. So that, you know, that's those that's one at least. A longer period variable star, and one of these intrinsic ones, I think it's intrinsic, is Mira, Mira, and I think that's in the constellation of Cetus, if I remember right. And that's what's called a long period variable. Its variability is more like a sine wave, right? So it gets bright and then it gets dark and then bright and then dark, as opposed to the eclipsing binaries, which are usually always bright and then dark and then back to bright again, just after a couple hours. So Mira is a variable star that I think has something like a 300-day period or so. And again, it's extremely noticeable. I think it actually goes to outside of our limits of visibility, and then it brightens up quite a bit. So yeah, so check out Algol and check out Mira, and those are two I guess I would call them starter types of things, because you don't have to have a telescope or binoculars or anything. You just need a relatively dark sight. Anyway, so I did not have in my OBS session, I did not have a second object to move on to. So I'm just sort of like, well, I have to work on this until I find it, right? I mean, that's the only thing I can do, right? But that, well, as I said, you learn things usually the hard way, and that, it is the hardest way, but it's also the best way, because you really remember, because you remember the pain, right? And yeah, that was a painful hour and a half of trying to find this thing. See, now, if I would have had a second target, right? If I would have had a second target, then I would have said, okay, I've been looking at this, looking for this one, for 15 minutes now. I'm going to move on, right? I'm going to move on to target 2, right? Now, if I would have had trouble with target 2, then I would have known, right then and there, that I was having a problem with the pointing, right? Because it turns out that was the fundamental problem, was that I just wasn't, the telescope itself just wasn't pointing very well. It was upwards of like a degree and a half off, and I'll show you the chart here. So yeah, I kept dialing it in, and it kept showing me the same patch of sky, and I look at it on my I look for any kind of star patterns, right? And then I look on the chart, and you go back and forth, back and forth, back and forth, trying to find some kind of pattern. Did not see a pattern. Didn't have a second object to move to. So I just stuck on this stupid thing for over an hour. The minimum of this eclipsing binary star took place at 4:29 UTC, right? Well, at 4:32 UTC, I looked at the clock. I was still hunting for this thing, right? So at that point, it's like, well, I missed the minimum, right? And of the entire light curve, the minimum is probably the most valuable part. All of it is extremely useful information, but when it hits that minimum, is helps others, to match that, to models, see what the differences are, and see if there are any kind of systematic differences there, which might be, you might have to take that into account by assuming that there's a third body or a fourth body or a fifth body or who knows what, right? So it was past the minimum, still hadn't found this stupid thing, right? And I'm looking at my temperature gauge thing, watching the humidity going up and up and up and up, right? Well, I was just about to just call it, right? Because it's like, okay, I'm past the minimum. I'm not really going to have a lot of valuable data here. I mean, it still is data, and it still has some value, right? But it's like, well, and right at that point, I looked up at my screen, I saw a pattern of stars, I looked over on the chart, and I found it. Bam, right? Now, I've been moving the telescope around, trying to look for different kinds of patterns. And that's what I've been doing for, well over an hour, right? Is moving the telescope slightly around, trying to find some kind of star patterns. It's like not seeing a thing, right? But literally at the last moment, right, I saw this. And so what I decided to do at that point was and I should have done this for the whole thing, right? But I started recording the images at that point, right? Once I'd found a pattern, then I'm like, okay, I'm going to record how I actually get over to my target, because it was, you'll see on the chart, it's like way off to one side. It's just a miracle I found it at all. But yeah, well, that's how those kinds of things go, though. So cheers to miracles. I like them. All right. So let me get you set up here. So what I want to do is show that, and actually I can show this too. Is there a way to? Probably not. Okay. All right, here we go. I'm going to share my screen again. Like that, and that, and that. Okay, so this is what I've got here. So what I was able to do is I recorded my entire path from when I first identified a pattern to actually acquiring the target. And it took something like 236 images. And so I just turned these into a little movie, which I thought that you'd like to see. It's actually pretty interesting. But here's my chart, right? And I'm going to zoom in here. So these lines, these grid lines, are just 1/2 degree, 1/2 of a degree apart, right? So as you can see, this entire radius here is therefore 1 degree, right? So this is 1 degree around there, right? So 2 degrees wide, or 2 degrees on each side, okay? So this smaller purple box here is my field of view, right? And centered right in the middle is my target. So that star right there is GQ tau. And I'm lucky enough, I was looking at this and it's like, well, cool. I've got a nice bright reference star in the same field of view. So that is absolutely fantastic, right? So if I can get this guy and this guy in the same field of view, then I'll be golden, right? So that was the setup, right? And I've got a 4 square degree field of view here, right? 2 on each side, right? So if the telescope points anywhere in this field of view, right, I will be able to know where it is, where it's pointing, and I'll be able to, you know, move the telescope gently, slowly over to where it needs to be, right? So, but that was not the case. It turns out that most likely I was way over here to the right. I was way over this way. Um,
And that's when you should have done some plate solving.
Well, yeah, no, that's a completely different thing. But no, I mean, what I should have done and what I'm going to do, you know, now is have at least, you know, one backup object. Spend, you know, 10 or 15 minutes looking for this one. If I can't find it, look for the next one. If I can't find the second one, then I can be pretty sure that I've got a pointing problem. And that's exactly what I had last night, was a pointing problem. I was telling it, you know, to point here, but the telescope was pointing way over to the right, way over there. So way off of my chart, I can't see any, you know, patterns that aren't on my chart, right? So anyway,
Time for you to update the firmware of that scope, or trying to get yourself a new scope.
well, you know, a lot of it has that has to do with the star alignment, right? If the star alignment isn't really good, then the pointing isn't going to be all that good either. And you know, I have to admit, I might have slightly bumped the telescope, so that is going to knock it out too, right? I, I I can't really confirm if I moved it or not. So, but that you know, might account for it as well. Anyway, but once I acquired it, I'm like, okay, I'm just going to record my entire path. So I'll just show you that here. As I said, I turned it into a movie. Now it's not a great one, but and I should point out too, you know, that this is raw data. So there's a lot of you know, bad pixels, which are these things, right? And you'll see when I play the movie that a lot of these dots here don't move, right? But you can sort of tell that, you know, this is a star, this isn't a star, that's a star, that's a star, that's not a star. It's, you know, I mean, it's hard to tell, and it makes trying, you know, me, you know, to pattern match, it makes it even harder, right? Because my brain is seeing all of these things, and I have to figure out how to ignore those and just look at the pattern of the stars, right? But I've done that, right? I mean, that's not a problem. So anyway, let me, I'm going to play this forward a little bit here, and we can see how this goes. So right about here, let me see if I can sharpen up those stars. Okay, so this is the pattern that I saw in my chart. And so what I was looking at here, right, is I was looking at sort of this shape, and then this row of stars here, right? So this almost a straight line, sort of a little bit of a curvy thing, and then this sort of like a pentagon, right? So that I finally found on the chart, and I'll show you on the chart where it is. I'll show you where it is. I don't know if you see it yet or not. Let me, it's kind of hard to do it on both. Anyway, here it is. Okay, so here's bright, faint, faint, fainter, and fainter, right? So bright, faint, faint, fainter, and fainter. So there's that, right? So it's flipped and reversed. So it's left, right, and up, down. And then this line of stars, this line of 4, right, goes bright, faint, brighter, about the same. Bright, faint, brighter, about the same. So there's this line of stars, and there's this thing that at least here, to me, sort of looks like a pentagon. And if you tilt your head, you can sort of see the same thing there. So this is where my telescope is pointing at this moment, right? Is right there. And as you can see, so it's looking over here, and my target is way over here, right? It's like almost a degree away. So I'm pretty sure I was over here even more, and I just so happened to go exactly the right way to run into these guys. So this movie is just how I moved from this location to this location, right? So I'll play it here, and then I'll probably pause it a few times just so we can stop and look at the charts. But anyway, so that's where I'm starting. And as you can see on the chart, right, this guy is above this guy. So I need to move upwards, right? So all the stars have to move down. I've got to go that way, because that way is to the left, which is exactly the way I need to go, right? So I definitely need to go left. There's going to be some course correction in here somewhere, right? And I think I almost got lost in this area, but I figured it out. But okay, so anyway, this is where we're starting, and I am basically just going to be moving that away, which in this case is almost due east. All right, so here I'm going to play this a little bit, and you can sort of see. So now you can see the stars moving, and the background, or the hot pixels. So here's an interesting little asterism. You see this thing that looks, to me, it looks like a clock saying 10:30, right? That's at about 10:30 there. But then, see, this guy has a little friend here, and this guy has a little friend here, and I think this guy has a little friend here. Let's, oh, no, he doesn't. He doesn't. So that was a hot pixel of some sort. But these two guys have little friends, and then there's this. So let's look for a pattern along that path, right? That looks like that. We can go over on the chart here, and let's see. Do you see it? I know it's hard, but it's right here. Okay, so here's this guy is this guy. Oh, move him over. So this pair, right here, is this guy. Is that right? No, I think that's a hot pixel. I think this guy's over here, actually. So here's these two guys is this one. And then this one is this one. And then this guy is this. And this is this. All right, so there we are. So we've moved from here to up here. So that's pretty good so far. Let's see. Let's keep going. Ooh, there's a bright one. Interestingly enough, look how incredibly symmetric that is. I think that is just pretty amazing. Big bright star, and then these two kind of bright ones here, and a faint one right up there. You see them? Well, just look for a bright star right there. There it is. So believe it or not, that is it. You can see it here, right? Here's the bright guy. Here's these two. Here's these two. And here's that one. Let's look and see if there's one over here and one here. I don't know if we can. Yeah. So, whoop. Yeah. So there's that one. Oh no, I think it's over here. So we need to look on the other side. Look on the other side. So yeah, here's that. Yeah, so here's this guy right here. And then this one's this one. And then this bright one is this bright one way out here. And these two pixels are in the right place, almost the right place, I guess. For these, yeah, not really. Okay, so let's keep going with this one. So here I am. I'm moving again. So let's see. I've basically just moved. Still going this way. Yeah, I must be. Yeah, I'm looking over here now. All right, so we're getting closer. See, I'm right here now. These three with that one, or with those two. Yeah, there they are. Okay. So then I get a little bit lost. I'm like, oh, wait a minute, I'm not moving the right way. See how I'm sort of scanning around. It's like, uh-oh. Now I'm lost. Oh, there we go. So I'll point out the target here when we get the other guy in. Okay, here we go. All right, so here it is. This is GQ tau, that guy right there. Here's the bright comparison star that I'll use. This star supposedly isn't changing in brightness. This one supposedly is. And so if I just compare the brightness difference between them, I'll see that it also changes. And that will show that it's a variable star. So yeah, that's just this, right? Let's see, can I put it over here? So you've got bright and fainter. That's this guy and this guy, right? And then we've got, let's see. I guess, yeah, this one is this one. And then you see these three right here, these three? That's these three. All right, and then on the other side, I'm not really seeing, I'm expecting to see a star, I don't know, right about there, right? Making a nice little triangle. And then this guy up here, which is this one. I'm not seeing that star. So don't exactly know.
Aerobics.
What's that?
Chuck Nagel, lots of aerobics.
Yes, yes, lots of aerobics. So, but anyway, that's how I moved from where I was, or where I started, to where I ended up. So there I was just moving around to sort of confirm. So here's the whole thing. So that's about where I'm like, I see a pattern now. And once I see a pattern, it's just nonstop. It's just go, 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 go. So you can see I'm basically moving in the same direction the whole time. Almost the whole time. Because then right about here, I think I figure out it's like, whoop, I think I've not going the right direction. So I make a few course corrections, try to get my bearings, and it's like, aha, got him. And there he is right there. There he is right there. Oh, moving around. I'm still trying. I don't think that I've actually identified it yet, but maybe at that point when I start centering him, I think that's when I'm like, aha, that's where he is. So yeah, I think this will be a great data set. I ended up only collecting about an hour's worth because the humidity rose, as I said, to 91%, and the front of my scope was just beginning to fog up. So I'm like, okay, show is over. So yeah, it's been a pretty wet winter here. So which is good, you know. I think, you know, the most valuable commodity in a desert is water, right? H2O, HOH, whatever you want to call it. And so we greatly appreciate all of our falling liquid out of the sky. Good stuff. And I hear the wildflowers are just absolutely fantastic. So I'd like to take a trip up and take a look at them. Anyway, so yeah, so I sat on this for, as I said, about an hour or so, collected 200 and, I don't know, 200 and some images. We can look at them. And that's about it. You know, it fogged up, I'm done. So I got a little bit of data. My expectation is that I will see this star brightening. I definitely missed the. I'm gonna stop this. Ooh, there we go. There's a nice infinity. Yeah. Where does it go? It just keeps going and going and going. Look at that. That's great. Anyway, so yeah, you know, when it gets too humid and the scope starts to fog up, the photometry must end because there's no good data on that. So I took my darks, and I already had my flats. I have yet to take the camera off the telescope, so it's still on there. Hasn't, as far as I know, hasn't been bumped, hasn't been turned, hasn't been twisted. The star images look really good. Nice and
how do you
round.
get your RGB filters up and play?
They're inside of here. Yeah.
Oh.
Yeah. So there's a filter holder. It's just a mechanism in there, right? It's got a little stepper motor, and I showed you some pictures of the filter wheel, and that just goes inside of there, and you know, it's indexed, so it knows um, 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 which filter is which, and so yeah, I just have to tell it inside of CCD Soft, which is the camera control and acquisition software. I just have to tell it which filter to use, and it'll rotate it, you know, to that one, and use that. So, but yeah, I've yet to take it off of there, so I don't have to do flats. So yay. I think the flats that I have look pretty good anyway. So yeah. So yeah, you know, I think I definitely would have been out there another hour if the humidity hadn't crept up. But as it was, I got an hour's worth. So I've got to reduce the data. You know, I've got to calibrate it. I've got to run it through, you know, the ringer. I've already got all the software written in terms of doing the analysis of variable stars. So I just have to remember how to run those programs again. It's been, I don't know, it's been a little while, a month or two. So I'll just have to remember how to do that. But yeah, I should have some kind of a light curve in the next couple of days. That's sort of the plan there. So, all right, well, you know, I'm looking at the time and noticing that we are after the hour. So, yeah, this might be a good place, a good opportunity to end the live stream for today. Can't see anything else going on in chat per se. So yeah, well, definitely everybody, happy Equinox. Now, you know, I am one of the few, right, that you will ever hear say this, right? But check your local time. See when 21, what was it? 21:58 UTC.
So that'll be
right?
20, 19, 18, 17, 4:58 for me. 4:58 p.m. Central Daylight Time.
Yes. Yeah. So what I am recommending.
You would be 2:58 p.m.
Correct.
Mountain Standard Time.
Correct. Now, what I am recommending is that if the sun is up at your location at the equinox, right, that you go outside. And now I'm not saying, right, I'm not saying stare at the sun, right? You know, I'm not saying get a pair of binoculars, right, and like look at, you know, no. You glance at the sun and wave and say happy equinox, right? You know, the equinox is nothing more than two lines intersecting, right? The ecliptic and the equator, right? So it just so happens that at the equinoxes, the declination of the exact center of the sun is 0 degrees, right? It's on the celestial equator. The path of the sun through the sky also draws a line that's called the ecliptic, right? And that's set at an angle, right? So those two lines intersect at an angle of 23.5 degrees, right? Because our Earth is tilted that many degrees to the plane of the ecliptic, which is a plane that is created by the sun and the earth. It's that orbital plane, right? So, you know, that's all that an equinox is the intersection of two lines, right? One like that and one like that. And the vernal equinox is when the sun is moving north, right? And the autumnal equinox is when the sun is moving south and crosses that same line. So it's a point in space, it's a point in time, and it is one of those shared experiences that we all experience, right? Together, simultaneously, right? There are no time zones, right? The equinox occurs at a specific time, right? So that, you know, it doesn't occur, you know, for me and then you and then you and then you and then you. No, it occurs for us all at exactly the same time. Now, 99.9% of the planet isn't even aware, right? And even if they are aware, who cares, right? But there's a very little tiny portion of the population on this planet not only is aware of it, but understands how absolutely incredible it is, right? And that's us. That's us. And you know, I feel I'm sorry for those who can't enjoy these kinds of little things, because it's you know, it's an intersection of two lines. That's all it is, right? But it's a really interesting coincidence, right? That happens twice a year, so it's great. Anyway, so if the sun is out at 21:58 at your location, go out, catch a glance, right? Just taste a few of those photons, right? Direct, right? It's okay. Don't stare at it. Don't be dumb, right? But you can catch a glance at the sun, no problem at all, right? Give it a wave, right? Say howdy, say glad you're coming up, and that's it, right? So I like these shared experiences. They're really great, and so you know, no matter what you're doing at that time, this event will happen, and you don't have to pay any attention at all. It'll just happen all by itself, right? Nobody ever has to pay any attention to this at all. It just happens, right? But it's these kinds of occasions that I like to mark. As I said, you know, the equinoxes and the solstices are my four favorite days of the year. Those are sort of my holidays, and I don't, you know, the only thing that I really do special is I'll definitely catch a glance at the sun, right? So yeah, for me that's what at 2:58 p.m. So you know, the sun will definitely be above the horizon. If it's cloudy, yeah, I'll sort of look in the direction of the sun and you know, do exactly the same thing. So anyway, I encourage you to do that too. I you know, I think the sun is pretty important. It seems to be pretty important to all of us, and you know, it just gives and gives and gives and gives and gives. Doesn't, as far as I know, doesn't take a thing, right? It's just giving, and so yeah, you know, I appreciate that. I think that that is pretty nice. That it is just giving all of this stuff that makes us go. I think it's just cool. All right, well, enough of that. I'm going to get out of here for now. So happy Equinox to everyone out there. Enjoy your day. Enjoy your evening. Make sure to subscribe if you haven't already. Hit the thumbs up if you so desire. Let's see. Make some comments. I always like to see those. I think I respond to most of them. Sometimes I think, it's like, well, do I need to respond to this? And it's like, yeah, I probably should, do that, and spread the word, right? That I guess the kind of crowd that I'm trying to gather around me isn't just anyone, right? I've already noticed that the people who are here are really interesting, right? And I know that I don't give you folks too much of a chance to blather on, but the tidbits that I've heard about many of you on here just makes me very, very honored, to be able to do this, and to bring such an amazing group together. So this, I'm not casting a net, right? So this is very, I mean, I guess I don't know if it's slow or fast. I don't have any means of measuring that. So I just think it's fun, and I'm sharing the passion, talking astronomy. Well, yeah, I do this throughout the entire day, right? I'm thinking astronomy pretty much all the time. Unless I have to think about other things, I'm thinking astronomical things. So, all right, everybody. Well, take care. I think what I might do tomorrow, if it's clear, is actually record the moonrise here. I think I've done that before. I'm trying to remember exactly. But anyway, I guess my friend is letting me know that it's about time to get on out of here. So I'm going to do just that. So take care, everybody. Peace, cheers, and all that. Live long and prosper. And I will see you in a little less than 23 hours. All right. Take care, everybody. Bye.